Yeah, this album is dedicated to all the teachers that told me I never amount to nothing. To all the people.
A sunspot is a dark spot of the sun's surface that is cooler than the area surrounding it. A sunspot is cooler because of a strong magnetic field there that inhibits the transport of heat via and extends out into the sun's corona. The magnetic field is formed under or below the sun's surface. The sun's corona is the thin gaseous envelope of the sun and other stars. The sun's corona is normally visible only during a total solar eclipse, when it is seen as an unbalanced shaped pearly glow surrounding the darkened disk of the moon. A sunspot can be thought of as a bubble of magnetic pressures surrounded by the gas pressure of the photosphere. A photosphere is the luminous envelope of a star from which its light and heat radiate. For the sunspot to exist, the total amount of gas pressure has to be in balance between the region outside of the sunspot and the region inside of the sunspot. Magnetic fields keep sunspots cooler. Sunspots are made of two parts: a dark, roughly circular central disk called the umbra, and a lighter outer area called the penumbra. The term umbra means shade in Latin. Penumbra means almost shade. The granular appearance of the area outside of the sunspot is the result of convection. The center of each granule is hot material rising from the sun's interior. While the edges are cooler material sinking downward, sunspots are moderately cooler than they are considerably darker. Still, if you could cut out a moderately sized sunspot and place it in the night sky, it would be about as bright as a full moon. In the last few decades, the forces behind sunspots are becoming better understood, but we've known for over 150 years that sunspots appear in cycles. The average number of visible sunspots varies over time, increasing and decreasing on a regular cycle of between 9.5 to 11 years, on average about 10.8 years. By studying the sun's magnetic field, modern astronomers have discovered that the cycle covers 22 years, with an 11-year cycle of sunspots above the equator, followed by an equal cycle below the equator. Sunspots most often appear in the low latitudes near the solar equator, and they almost never appear below 5 or above 40 degrees north and south latitude. As the sunspot cycle progresses, the visible sunspots move gradually towards the equator. Sunspots also have an indirect but significant impact on life here on Earth. As early as the 19th century, scientists noticed that high levels of activity on the sun, like flares and sunspots, were followed shortly by strong fluctuations in magnetic instruments on Earth. Even though sunspots are darker, cooler regions on the face of the sun, periods of high sunspot activity are associated with a very slight increase in the total energy output of the sun. Dark sunspot areas are surrounded by areas of increased brightness, known as plages. Some parts of the solar spectrum, especially ultraviolet, increase a great deal during sunspot activity. Even though ultraviolet radiation makes every little contribution to the total energy that comes from the sun, changes in this type of radiation can have a large effect on the Earth's atmosphere, especially the energy balance and chemistry of the outer atmosphere.